Assalamu alaikum. We know the opposition to the flow of current is known as resistance. In this video, we are going to learn about resistance and resistivity with the help of few simple experiments. Here I have a pencil lead which is made of graphite. We know graphite is an allotropy of carbon. Though it is a non-metal, but it conducts the current. Now I am going to measure its resistance with the help of a multimeter. For that, I'll set this multimeter to read the resistance. I'll place the probes of the multimeter at the ends of this lead. You can see it measures the resistance. It is around 9 ohm. When the probes are placed at the end, it reads around 9 ohm. Now I'm slowly going to reduce the length by bringing them close. See, as I'm bringing these probes close, with the decrease in length, resistance also reducing. This shows that resistance to the flow of current offered by a conductor is directly proportional to length of the conductor. I'll repeat this once again. This time I'll place the probes very close to each other. Now slowly I'm going to increase the length. See, as I increase, the resistance increases. This shows R is directly proportional to L. When L increases, R will also increase. Now I take two pencil leads made of graphite. They have same length but different area of cross section. The area of cross section of this lead is more than this pencil lead. Now I will check the resistance offered by these two pencil leads with the help of multimeter. I have set the multimeter to read the resistance. First I will check the resistance offered by thick pencil lead. See, it is 8.5. Now I'll check the resistance of this thin pencil lead. It is 12.5. This shows that this pencil lead provides more resistance compared to the thick pencil lead. This shows that the resistance offered to the flow of current by a conductor is inversely proportional to the area of cross section of the conductor. I will perform one more experiment to show the resistance offered to the flow of current by a conductor is directly proportional to the length of the conductor. For that, I have connected a pencil from which I have removed the wooden part to become the lead visible. Here, this pencil is connected to the negative terminal of the battery and the positive terminal is connected via bulb. Now, I touch this part to the lead of the pencil. See what happened? When I do so, the bulb do not glow. Now slowly I bring this end towards right. When I do so, you may find the bulb starts glowing. As I move towards right, the brightness increases. You can see as I am coming close to the right side, the brightness increases. When I have become very close to this, the brightness has increased. This due to the reduction in the length between these two terminals. This shows that the resistance has reduced with the decrease in the length between these two terminals. I'll keep it here once again. Let's see. Here the brightness is more. Now I'll move in the opposite direction. Now I'm going to increase the length. When I increase the length of the conductor, you can see the brightness, very less current flows through this bulb. So the brightness is decreasing as I move away. And at one point, due to the highest resistance, the bulb is glowing hardly. Hardly can view the bulb glowing. This shows that resistance offered to the flow of current by a conductor is directly proportional to the length of the conductor. Let me get the expression for resistivity. According to our observation, resistance offered to the flow of current by a conductor is directly proportional to length of the conductor, and it is inversely proportional to area of cross section of the conductor. When we combine these two, we get this expression. Here, this symbol stands for proportionality. When we remove this proportionality, we need to include a constant along with equal to sign. This constant is the representable letter rho. Here this is called as letter rho, and it stands for resistivity. So from here, rho will be equal to Ra upon L. Resistivity is a reciprocal of conductivity. Resistivity is a reciprocal of conductivity, which is represented letter sigma. You remember this. Here, the unit of resistance is ohm, denoted by letter omega. In similar way, unit of resistivity is ohm meter, denoted as omega m, omega meter. How do you get this? The unit of resistivity is obtained something like this. Here we have the expression for rho, which is R A upon L. We know area can be obtained by multiplying length with the breadth. Here, if L equals to B, then the above expression can be written as R L into L upon L. So this L and this L will cancel. And what is obtained here is something like this. Rho is equal to R L. The unit of R is ohm and the unit of L is meter. That is why we obtain this unit for resistivity. I hope you have understood. If we consider the length of conductor equals to 1 meter and the area of cross section equal to 1 meter square, then by substituting the value of L and A in this equation, we get a rho equals to R into 1 upon 1. That means rho equals to R. This shows that resistivity of a conductor is equal to resistance offered by the conductor to the flow of current. When a current flows through the conductor having length 1 meter and area of cross section equal to 1 meter square. And here different substances have different value of resistivity. Resistivity is maximum for insulators, which are also called as non-conductor. They do not allow current to pass through them. And it is least for conductors. And there is one more object or substance called as semiconductor. And a semiconductor. They have resistivity in between insulator and conductor. So we can say they have moderate resistivity. Now, I hope this video is useful. If you have any kind of doubt related to the topic, kindly put your questions in the comment section. Thanks for watching.